All right. So we know that whenever they ask you the maximum number of minimum or maximum possible, we just write theta equals to 90, right? We input theta equals 90. Moving on. Careful when calculating d. Why do I say that? Because diffraction grating এর sums এর d এর value direct দিয়ে দেয় না. They're always like a diffraction grating has 3000 lines per centimeter. Now d is basically the slit difference প্রত্যেকটার মধ্যে, right? So what does this mean? This means that in every centimeter there are 3000 tiny holes. Now what is the difference between those holes, or what is the distance between those holes? It's basically the 1 centimeter, like per centimeter, 1 centimeter divided by how many holes there are, or lines there are, 1 by 3000, which comes out to 3.3 into 10 to the power minus 4. Now it's always good practice to convert all your units to the same unit. So I'm always like centimeter take always meter convert করনিং, right? You know, by multiplying it by 10 to the power minus 2. So it just comes to this, right? 3.3 into 10 to the power minus 6 meter. So do that, right? So imagine they tell you like the diffraction grating has like 5,000 lines like every centimeter. So you just divide it by 1 by 5,000. And that's basically it, right? And then input it in D. So moving on, we're going to learn how to do resonance tube sums, right? Before we do that, I'm going to just একটু হালকা overview দিয়ে of standing waves. Now standing waves, the definition টাই হচ্ছে that they don't propagate any energy. Like energy কোথাও আসে মানে progressive waves হচ্ছে basically energy is like moving in a certain direction. Standing waves is basically এক জায়গায় they just kind of, you know, vibrate like a guitar string, right? Standing waves এর দুইটা notable জিনিস হচ্ছে nodes. Basically these are the points which don't move at all. See, এই লাস্টের পয়েন্টটা যেখানে fixed, right? And antinodes, these are the points that move the most, right? Few things that we have to remember is that if we're ever like working with nodes and antinodes, the difference between node tag the middle and up, the difference between two nodes is always half lambda. All right? The difference between a node and an antinode is always 1 by 4 lambda. All right? The difference between two nodes is half lambda. The difference between a node and an antinode or antinode is always 1/4 lambda, right? See, because it's 1/4 of a wavelength, right? That's 1/4. And then there's another 1/4. So দুইটা মিলে half, right? Get it? Yeah. So একটা antinode আর আরেকটা antinode এর মধ্যে difference is half lambda. These are like just things to remember. They come in handy when you're doing sums, right? All right, moving on. So basically usually আমাদের resonance tube sums দেখতে এমন হয়. So there are like two resonance tubes. দুইটাতে পানি ভরা থাকে, right? Like water. I'll denote the red part is water, right? And then there's another tube like which is the same, right? এটাতেও পানি থাকে বাট একটু নিচে, right? Right? Something like this. And then এখানে like different patterns form হয়. Like basically the open end, this is basically the open end. This is the part where যেখানে কোনো lid নাই. This is called the open end, right? For both of them, right? এখানে always antinode থাকে. Antinode, right? This place always has an antinode. Alright? And the closed end, the part where the particles, এখানে basically air particles গুলো, whenever they try to vibrate, they just hit the water and just stop and just lose their energy. এখানে whenever the air particles try to vibrate, they hit the water and they kind of lose their energy. এখন thing is এই জায়গাটাতে vibration হয় না. So this is the node, right? This is always the node. Alright? Now এরকম এটার সামস গুলো এক্স্যাক্টলি কেমন হয়, রাইট? সো আমি বললাম যে দিস ইজ দ্য ওপেন এন্ড, right? The antinode, and this is the closed end or the node, right? Great. So এটা একটা sum দেখি আমরা, basically resonance tube sum. There you go, right? See, there's one. So একটা tuning, a long tube filled with a tap is fitted with a tap is filled with water. Tuning fork is sounded above the top of the tube as the water is allowed to run out of the tube. First এটাতে এরকম প্যাটার্ন, তারপর এটাতে এই দুটার মধ্যে ডিফারেন্স দেওয়া, right? What did they ask? Sketch the form of the stationary wave set up in the tube, like this one, and mark with the letter N the position of any nodes and antinodes. And then they ask us to find the speed of the sound in the tube given the frequency. Basically আমাদের wavelength বের করতে হবে আর কি, right? So what does that look like? One thing that you have to remember about resonance tubes like this is that there's some usually bole that there's a loud sound, all right? There's always like a loud sound, and like ekhane ekbar ekta loud sound hoise, and this tuning fork just keeps vibrating, right? So when the water is at this level তখন একটা loud sound হয়, and then the next time মানে water কমতে 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 tuning fork is still vibrating, but there's no loud sound, no loud sound, no loud sound, no loud sound. But then যখন এখানে চলে আসে exactly 32.4 centimeters, তখন যে আবার আরেকটা loud sound আসে, right? So what exactly is happening? Basically this part is basically 1/4 of a wavelength, right? See, if we draw a wave, right, like a standing wave like this, AJ, this part, like AJ, see this part, এতটুক, right? Like এতটুক, just this much. That's the part that's been shown here, basically. If we drew out like eta, right? This is like 1/4 of a wave, and then eta pore the whole wave kind of like, this is half of a wave, and then abar, and then abar. I know it's very ugly, but like you get it, right? You get the gist. This is basically 1/4 of a wave. এখন, whenever the loud sound is heard, that's called resonance. Jacha. This basically, this tube is resonating. Resonance টা কোথায় হয়? Resonance টা always হয়. Let me just show you. Let me just tell you. It always happens at these wavelengths. 1/4 lambda. This is so inconvenient. Right. At 1/4 lambda, 3/4 lambda, 5/4 lambda, 7/4 lambda. এরকম. They always happen at 1/4, 3/4, 5/4 or 7/4 lambda. ঠিক আছে? So first হয় 1/4 এ, then হয় 3/4 এ, then হয় 5/4 এ, then 7/4 lambda তে, right? এখন কথা হচ্ছে, what exactly does that mean? What exactly does 3/4 lambda mean, or 5/4 lambda mean? Okay, let's look at that. Let's see. So if you look at this, what is 1/4 lambda? 1/4 lambda is basically এতটুক, right? This much, right? Yeah, that's basically 1/4 lambda. So when the wave pattern looks like that, তখনই হচ্ছে, see, resonance হয়. আবার 3/4 is basically here, this whole part. Sorry about that, blur হয়ে গেছে. This whole part, এখান থেকে এই পর্যন্ত, this is 3/4 lambda. ঠিক আছে? So it kind of looks like 8. Alright? So আমি যদি স্ট্যান্ডিং ওয়েভের এরকম করে প্যাটার্নটা কমপ্লিট করে দিই, So it looks like this, right? So see how এদিকে একটা open end আছে and এখানে একটা close end. So basically টিউবের মধ্যে it looks like this. So imagine এখানে আমার water, right? And this end, this is the node. ওইটা থাকে এখানে, right? So it looks somewhat like that. Somewhat like that. Like a little fish, right? এখানে একটা নোড, এখানে একটা নোড, আর এখানে এই যে এই open endটা, right? The anti-node, all right? So, and then the little 5x4, 7x4, you know, depending on what the wavelength is, right? So, এমনি করে basically আমরা wave pattern draw করি. We basically break down the wave into different parts, and then we draw them, right? So, এইখানে the first time it hears, right? See, a tuning force is sounded above the top of the tube as the water is allowed to run, right? A loud sound is first heard when the water level is as shown in figure 6.1, which is this one. So that has to be 1/4 lambda. The second time, and then again when the water level is at figure 6.2. So this one has to be 3/4 lambda, and 3/4 lambda looks somewhat like that. যেখানে this part is a node, this part is a node, এই পার্টটা anti-node, এই পার্টটা anti-node, right? এখন কথা হচ্ছে how do we determine the wavelength from this, right? So এখানে আমরা আঁকি, like first একটা আঁকি, this is 1/4 lambda, right? So it looks somewhat like, yeah, that's what it looks like, right? And then eta, right? So 3/4 lambda. So basically 3/4 of a wavelength. So that this is so basically this is 1/4, this is 2/4, and this is 3/4. So basically এখান থেকে নিয়ে এই পর্যন্ত, right? So আমি যদি প্যাটার্নটা এই যে স্ট্যান্ডিং ওয়েভের জন্য যদি প্যাটার্নটা কমপ্লিট করি, looks like that, right? So এখানে থাকবে নোটটা, right? And then এখানে থাকবে, it looks somewhat like that. That's the pattern that will see, right? এই যে see A, right? এই পার্টটা আর আসতেছে না, right? Like a fish, right? Great. এখন কথা হচ্ছে এই পয়েন্ট আর এই পয়েন্টের মধ্যে আমাকে ডিফারেন্স দিয়ে দিছে 32.4, রাইট? ডিফারেন্স দিয়ে দিছে 32.4, সি ডিফারেন্স দিয়ে দিছে এই পয়েন্টটা আর এই পয়েন্টের মধ্যে ডিফারেন্স দিয়ে দিছে 32.4, রাইট? গ্রেট। সো 32.4টা দিয়ে আমরা কি করবো? সি ইফ দিস ইজ 3/4 lambda, right? This much is 3/4 lambda, and this much is 1/4 lambda. এইটা থেকে এইটাকে যদি আমি মাইনাস করি, we get 3/4 lambda minus 1/4 lambda is equal to 1/2 lambda, which is 3/4 minus 1/4, which is 0.5. এখন 1/2 lambda ভ্যালু কত? 32.4, right? এতটুক হচ্ছে 1/2 lambda, because 3/4 minus 1/4, 3/4 minus 1/4 is এতটুক, right? এই পুরোটা থেকে এতটুক মাইনাস করলে we get half lambda. So if half lambda is equal to 32.4, lambda is equal to 64.8, right? So this is our wavelength. So that's how we find out wavelength. So that's how we find out wavelength from a resonance tube sum, right? So eta jodi hoy 1/4, and if this is 3/4, total to 3/4 থেকে 1/4 minus করলে এতটুক থেকে যায় হচ্ছে half lambda. So I hope you understand that. And remember, resonance always occurs at these following মানে wavelengths আর কি 1/4 lambda 3/4 lambda 5/4 7/4 alright great so first 1/4 then 3/4 you know so I hope that was understandable alright moving on to cathode ray oscilloscopes now this is going to be alright abar fireworks shuru hoyse. So this is going to be too short because there's not much to it but the thing about cathode ray oscilloscopes is they're basically screens that display like waves right always remember horizontal axis e time base thake the horizontal axis is always time base settings time base theke amra ki kori time base settings দিয়ে we find out frequency okay how ekhane amake dawa see every single square is of 1 centimeter by 1 centimeter square right time base setting dawa 2 millisecond per centimeter tar mane every single centimeter like on the horizontal axis represents 2 milliseconds right and that basically gives us the time period so ekta pura wave complete korte amar koto millisecond lagche na dekhi to right so you have 1 2 3 4 5 6 centimeters right 6 centimeter right so every centimeter e jodi 2 thake 6 centimeters amar thakbe 6 into 2 that's 12 milliseconds right every centimeter has 2 milliseconds so 6 centimeters will have 12 milliseconds and that's the amount of time to calculate one wave to make one wave এখন কথা হচ্ছে to find the frequency obviously we have to divide this is t right so to find the frequency we have to divide it by 12 and then we have to basically convert this millisecond into seconds and all of that right so 1 by t so we know this we can do that I hope it's understandable because see every centimeter the horizontal axis the horizontal is always the time base gives us the time period of one wave right একটা wave বানাইতে আমার 1 centimeter 2 centimeter 3 4 5 6 centimeter if it's 6 centimeters per centimeter যদি 2 milliseconds so total wave time period একটা wave time period is 6 into 2 12 milliseconds right great the vertical axis kind of gives us the amplitude right now the problem people face is when they're shifting the time base settings for example I want to draw this same wave this exact wave but এবার আমার horizontal time base settings is 3 millisecond per centimeter আগে every centimeter represented how many milliseconds 2 এবার every centimeter represents 3 এখন এটার টোটাল টাইম পিরিয়ড কত ছিল 12 milliseconds right এখন এটা চেঞ্জ হবে না when we change the time base settings always remember the wave itself isn't changing the way that CRO is displaying the wave that's changing the wave itself doesn't change waveটা তোমার 12 millisecond time base ছিল এখন 12 millisecond আছে but on this new axis যেখানে every centimeter is 3 12 কে represent করতে আমার কয় সেন্টিমিটার লাগবে unitary method 12 divided by 3 is 4 so 1 2 3 4 4 centimeters আমার total একটা wave থাকবে so that means half of a wave one wave and there you go and the horizontal axis is basically shifted in the same way I hope that was helpful for you guys and I hope I was able to clear out a few problems do send me like sums that you had problems with in your question papers and I will definitely try to solve them and help you out right thank you join Rob sir